do this. I want January the 22nd. All right, let's see what we have today. I feel like I've done this before. Nope. Count servers that communicate. N by N grid. 1 means that the cell is a server and 0 means it is not a server. 2 servers are set to communicate if they are on the same row on the same column. Return the number of servers that communicate with any other server. Return the number of servers that communicate with any other server. So basically return the number of ones that has at least another one on its row or on its column, right? Let's use this to test our theory. So this is a 4x4. 1, 2, 3, 1, 2, 3, 1, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 1. So everything on the row communicate. This one doesn't, this one doesn't, this one doesn't. So we get 2. Everything on the columns, we got 2. So 4. So basically we do, but we might overcount, right? That's the fear. Because if I have another one here, and then we go row, we got 4 already. Now when we go column, these 2 are already considered. So I need to change them into another value. For example, every time I go through this, I change it to 2. Change it to 2. So now it's going to be 5. Let's see if it is 5. So we add another case by changing this into 1. Yep. Okay, so we just go all the rows. But how do you know? You have to go it twice if you don't. Well, what I think is I can go through, whenever I have 1, I will just turn it into 2, and I record its position, right? And then at the end, we'll also count. If the number of count is larger than 1, then it's good. If it's equal to 1, then I change that one back to 1. Ugh, I think I just did something wrong. Should be 23. Okay. So we go through 2 times, right? We go through 2 times. We go by the rows and then by the column. Okay. So let's say I'm not sure if we have. Okay, we always have. That's good. 0 I smaller than m plus. Okay, and then we have count and I jj. That's stupid. Let's call p. Let's call r and c. Okay. If grid I j is equal to 1, r equal to I, j equal to, no, c equal to j, and then count plus plus. And grid ij, let's set it to 2, right? And as we go through everything, we say if, oh, we also need a result. Right, we say if count is equal to 1, then grid r c going back to 1. Right, so that's that. And else, right, if count is not equal to 1, then rest of plus equal to count. Okay, so now we'll do the exact same thing. For the column. Actually, I don't even need this because it's totally fine. We can just say count plus plus, right? And then once we get out, we just say if count is larger than 1, then rest plus equal to count. And then at the end, we return count, return rest. I shall do. The second case. Ooh, I see. That's right. So this is fine. If it's equal to 1, I do this, and at the end, yeah. Here, if it's, ooh, we need 2 counts, right? So count 1 and count 2. So we say if it's equal to 1, no, if it's larger or equal to 1, if grid ij is equal to 1, then this if it's not, then count 2 always plus plus. Right, and then we say if count 2 is larger than 1, then rest plus equal to count 1. First do row by row. Right, count the number of computers. If the count is larger than 1, we add a count to the result. Also, we mark the counted computers as 2 on a grid. Then do column by column, count the number of computers and the number of unmarked computers. If the total number of computers is larger than 1, we add the count of unmarked to the result. Yep, that sounds about right. Try it. Alright, that looks pretty bad. Only 43. Alright, now I'm suspecting there may be a one-pass solution. How would you do it one pass? One pass. So we go through, right, and we count. So we get a good count, and then we'll also mark the number on the column. So every time we do, we'll mark, yeah, well, we can do that. So we just get the columns. Yeah, we keep count on the columns. So once you get to a new row, at each cell you find how much is in the column, and if it's, then you add it. Okay, so that's kind of a second solution. Let's see how this one goes. Okay, so again, these are, doesn't change. Right, then we do std vector int count columns. Let's make it n column. Now we start at 0. Okay, now we say for int and also res. Okay, and now we say for int I, 0i, smaller I, plus plus. Okay, so for each one, we also have int row count. Count row, okay, count row. If grid ij is equal to equal to 1, right? So count row plus plus plus, and then count columns j plus plus. Then we say if count row is larger than 1 or count columns j is larger than 1, res plus plus. And then at the end we return res. So use auxiliary space to keep track of the count of computers for each column. We can solve the problem in one path. Alright, let's see how this one goes. much simpler as well. Oopsie doozy, that is not right. What the hell? The second one is not right. Okay. Oh, yeah. Because you do this is a single one. So this does not get counted. Oh my god. Oh, and then we do this. Now the column count. This is not right. Now the column count is 2. But then the other one we already missed. So we have something that we didn't count. And now I hit here. How do I know this one has not been counted? Man. How do we do this in one pass? But maybe we can do, I don't know, 2 pass simpler. So when I hit one, nah, that doesn't sound right. So let's say we do a row count, right? But then you need to do a column. Is it really possible to do it in one pass? I mean, how can you do one pass? Alright, how can you do one pass while also considering the column? Because the column wise, the only way for you to recognize it is, I feel like there should be a, or you know what, maybe we can think about it the other way. How many computers are not connected? Right? How many computers not connected? So to find that answer, how many computers are not connected? Maybe, you know, if we go rows, right, then if we go rows, then we say this one is not connected, this one is not connected, and this one is not connected. Then we go columns, right? Then we go columns. Oh, you know what? I don't know. Is there a way to do it in one pass? Row force. Tracking use 2 arrays. Alright, row count and column count. So they count the rows, they count the columns, okay. So for the rows and for the columns, but then how do they combine the two? Like I said, a row has more. So I have to go through them one more time. I have to go through them one more time. Okay. think I know what this means. So basically, in addition to this, for each column and rows, then go through the grid again to check whether a cell belongs to row and column that both have more than one machine. So in this case, we do need 2 rows. So first pass is basically right, and then second path, I feel like you have to have 2 paths. If grid, right, ij equal to 1 and equal to 1, say rest plus equal to count rows I larger than 1, or count columns j larger than 1, and then return rest. Okay, so this solution is from the official solution. Yep, you have two paths. Trying to hunt for a 1-path solution, but does not seem like it's possible. All right, the next question is grouping. This grouping idea is interesting. Grouping, wow, this is much faster than the other way. They're all 2 rounds. I don't know why. Because you have a lot of if and else, I guess that's why. And then restart the values. Maybe these all count. Anyway, this is 4 milliseconds. This one is 10 times faster. All right. They say grouping. I don't know what this server grouping means. Okay, initial state. Last server in columns. Row counts. Last server in row and column 1. Huh? The goal now is to micro-optimize the process. I don't think we're repeatedly checking. We just check the same thing. It's just a 2-pass, right? We use another array, last server in column, to track the position of the last server. The last server in each column. Because if a column has multiple servers, we don't need to check the entire column again. Instead, we can focus on whether the last server in the column is part of a communicable set. If the last server in column is 3, it means the last server in column 0 is at row 3. If this server communicate indicates that there are other servers in that column, and we can mark it as communicable without needing to scan all rows again. Okay, let me just read a code. Sometimes I think reading a code is easier to understand. So we count row counts last server in column. Row is column. With more than one server, increase the count. And last server in column, in row. Now in column, row, set to reset this value. For row, last server is not equal to -1. And then row counts last, that row, right, is larger than 1. Last server in column. Okay, I don't really understand. Last server in column. Size grid. And row counts. Size grid. Hold on, row counts column. That's not row counts, that's a column count. That is a column count. We are counting the columns. So we're counting the columns and we are counting the rows. Okay, so this is a column count. This is a row count. And this is a column count. We're saying, I mean, yeah, I call it row count, but it makes more sense to me to call it column count. Like how many in this column, right? So how many in this column? And then last server, this is in row. Right, last server in this row. So we get a last server in this row. That's fine. And then we go through all the rows. Last server in row. And for a row, for a row that's completed, right? That means we don't have to consider this row anymore. So I reset this one. Okay, so for each So like we'll go through the rows again. I'll go through all the rows again. But for each row, if it's -1, that means we have considered this row has sufficient, right? The ones that's not is we only have 1. If on the row we only have 1, then we need to know what it is. And based on what it is, we check how many in this column. If it's good, then we add it. That's actually not too bad. You know, that's actually not too bad. I think it's worth it. I think it's worth it to explore it. Because I understood. Okay, so this is also from the official solution. It is a bit convoluted, but it does reduce the number of operations, right? Observe that if there are more than 1 computers in a row, we can easily count all of them, and none of them should be counted again when we go for columns. So the only situation, the only computer that we should add when we do columns and after we have processed the rows is a single computer in a row that is part of a multi-computer column. Thus, we need to keep count of the number of computers in each column, and at the same time, mark where the last computer is on a row, right? If the row has only 1 computer, right? If the row has only 1 computer, yet the last computer on the row happens on a column of multiple computers, it should be counted, right? So I need a count columns. Well, right, so this is start. So count columns. No, count column is not that. N, right? So this is a count columns. And then we need rows, right? But we need count rows. So we count columns, and we should not count rows. Say vector int last computer on the row. All right, for each row, for each row, what is the J? What is the position of the last computer? Then for int I, 0i smaller than n, plus for j, Okay, we also need rest is equal to 0 and count row. Right? Now we say if grid ij is 1, count row at plus plus, count columns j plus plus, last row I equal to j. We set to -1, right? Once we're done with this, we say if count row is larger than 1, then rest plus equal to count row and last I. Right. All the computers have been considered already. Right, so we go through this. Once we're done, we'll go through we go through each row again. So m I plus plus. Right. If last comp row I is larger than equal to 0, right, this means this row has only one computer. Rest plus equal to count columns last comp row I if it's larger than 1. We will count it if its column has more than one computer. And then we will return rest. Yeah, same runtime, but plus n, right? This is not plus, it's not 2 pass, it's like 1.5 pass. Yeah, that sounds about right. That is, we achieved. All right, good. Like how do I open it again? Okay. All right, done. I'll see you guys tomorrow. Adios.